Well, everyone, welcome to our Series 65 presentation. My name is Sawyer Heidesch. I'm the Territory Manager for the Midwest, and I'm based out of Sioux Falls, South Dakota. A short backstory on AVK. We came to the US in the 1980s, and we have our factory set up in Minden, Nevada. From there, we have two warehouses, one in Nashville, Tennessee, and one in Omaha, Nebraska. These distribution locations allow for distribution of in-stock products within 24 to 48 hours. So today we'll be going over some broad aspects of our Series 65 valve. We'll give a beginner's level review on our gate valve and its main features. We'll then show you a bonnet swap and O-ring replacements. We will then have a discussion from our Eastern US sales manager, Kent Culbertson, on the importance of testing our water systems with water. If anyone is interested in the full Series 65 and Series 45 breakdowns, those go into a deeper discussion of standards and materials. We'll have the link for that available at the end of this presentation. And also at the end of the presentation, we'll be giving away some AVK swag. You can see the coffee mug on the screen. So be sure to pay attention and answer our trivia question at the end. So a recap for anyone new to the industry on what gate valves are. Gate valves are one of the most common valves used in water distribution systems and are suitable for both above ground and below ground installation. These valves are typically used for on-off service and are installed in pipelines as isolating valves. When we say isolating valve, we mean that you would install a valve in an accessible location so that you can shut down the flow of water to anything on the other side and isolate that area for whatever you may need. Your most common example of this is that the majority of fire hydrants in the ground today have an isolating valve directly in the vicinity so that you can turn off the water flow to that hydrant and perform maintenance on it safely. One of the most common issues that we hear about valves is that people have their stem breaks all the time. Our answer to this problem is that we provide a stainless steel stem as a standard feature in our valves. This allows for a much stronger resistance to over-torquing and a higher resilience to corrosion. Now, most of the time I mention corrosion, I'll bring up the state of Minnesota. The whole place is riddled with hot soil pockets and they're constantly fighting corrosion. Now, the stainless steel stem is a big deal for the guys up there that need it. Not only is it a stronger material, but our process of making a stem out of the steel shaft keeps as much structural integrity in the stem as possible. So when most people go to put threads in just about anything, they machine the material out of that shaft, and then the threads are what you have left. By doing this, you're compromising the integrity of that material and its makeup. By doing that, the material now has weak points that can allow it to break under high stress. All right, so as you can see, this is a process that we use called cold rolling. So as you can see, we take that steel shaft and through weight and force, we press the threads into that shaft. This keeps the structural integrity of the steel just as it is when it's made. This also creates a flawless stem that doesn't have any burrs on the threads. Now that might seem minor, but not only will you not cut your hand on the stem when handling it, but there's nothing that could catch on the wedge and stop it from traveling on the stem. Obviously that is a big deal because when you've got a situation downstream, you want to know that that valve is going to operate as needed. So now we were talking about corrosion. Our next feature is arguably our greatest and most effective feature to ensure the long-lasting life of your valve. So we provide a standard 3/16 stainless steel bolt to secure your bonnet to the body. Now this seal is an extremely important aspect to the longevity of a valve. If your bolts begin to deteriorate on a valve under pressure, it won't take long for that valve to start leaking. Not only are these bolts provided as stainless steel, but they thread into a blind bolt hole in the body. That means that your entire bolt is threaded into an enclosed space. And on top of that, we then put an industrial strength hot glue melt. So your bolt for its entire life will never see a corrosive soil or element, another winning aspect of these valves is our gasket, but you'll have a more up close look at that in a few moments. Before we get into repairs and maintenance, another great feature is our wedge guides. Now, in most other valves, you have a recessed groove in the valve body that the wedge will fit into once it's closed. This can cause debris and gunk to collect in that recess in the casting and not allow for a complete seal. You then have to get in there and clean it out and perform maintenance. Whereas, as you can see on our wedge guides, can you see my arrow, Ann?
It's offset again by a couple inches.
Is it? Okay. I'm sorry, guys, that we didn't get that part figured out. So where you can see the green gunk, those are our wedge guides. And we've reversed that process so that the wedge guides extrude from the valve body and the wedge actually rides up and down on the guides. This not only can remove the debris as the valve is operated and then it sends it downstream with the water, but it also keeps that wedge in a straight up and down operation, as you can see here from above. This animation also gives you a great description of a non-rising stem and how that wedge rides up and down inside of your valve body. Okay, so as you guys can see on the top of your wrench, or on the top of your valve, is your wrench nut. And as you can see, the only thing holding that on is a small bolt and washer on top, which is perfectly sufficient to hold the wrench nut on. However, most people use that wrench nut to lift the valve down into the ground. So that means the entire weight of that valve is being put on that small nut. If I'm the guy in the hole, I like a little more peace of mind than that. And so we've designed the lifting lugs that you can see just off to on the side of the valve underneath the wrench nut. So those are designed to lift the entire weight of the valve. And you can see the bolt as well right underneath the wedge there, or the wrench nut, so that you have two of those bolts those are taking the entire weight of your valve. These are a great feature, and it just simply helps keep your work site a little safer. Okay, so now the animation's coming. Okay, now we'll get into some repair discussions. We'll show you guys how to replace the wiper ring and gland flange, as well as the O-rings. While performing this portion of the maintenance, your line does not need to be shut down. We won't be digging deep enough into the valve to be at risk of danger. However, you are going to get a little wet from water coming out of the top. It is also very important to note that when performing this task, that to be sure that your valve is all the way open and your wedge is in the upright position. If it's down, the water pressure can force that wedge and the stem up, and the stem's not going to come up out, but it can cause some serious harm if you're not expecting that. So first, you're going to take the bolt and the washer out of the top, which the animation already did for us. And then your wrench nut itself comes off, and you'll have that off. You'll be able to see the serial number once you take that off. So you can see our serial number here. And that serial number provides complete traceability for us. It shows us everything we do at the factory, hydrants and valves, is tested with water. And so that serial number provides us with traceability for the pressure tests that it tested that day, as well as the guy who did it, the PO it was ordered on, the company that it shipped with, everything you need to know about how that valve got into your hands. We keep that in the system. This also helps traceability for the future so that we can document any things that have happened in the past. Our quality assurance can prevent further issues in the future. So next you take your gland flange bolts, and those will come off. And we'll get a better look at our wiper ring. This wiper ring is a great feature. A lot of operators are very happy with this. And as you can see here, that wiper ring is set into your gland flange there. And so what this wiper ring does is, as you guys know, the bottom of that valve box, from time to time, it'll fill with dirt and sand and gunk, and, city guys will have to get in there with a vac truck and suck it out. And so when you do have to get down there and perform maintenance on this, when you take that gland flange off, that wiper ring is going to clean your stem and make sure that there's no gunk and debris that's falling down into any crevices or your bolt holes or any of those other issues you may run into. And so now that you have the gland flange off, you also have your O-rings and your nylon bushing. Now you're simply going to replace your bushing and your O-rings with new ones, and then you'll put it back all together. So as you can see, you've got your top and your bushing and then your lower one. And then you have your third one, which creates your seal on the top of the bonnet. And so again, once you've got those out, they pop out, pop right back in. And again, on the wiper ring, it is cast into your gland flange. So if there is damage to that, you'll have to order a new one of those as well. When ordering parts, we do have parts kits for the gland flange and O-rings. And so your best bet is contact your territory manager or customer service, and we'll help you get those ordered for you. Some of you may be wondering what could cause the valve to have issues that would require new parts. One of the events our operators will run into is when your system is tested with air instead of water. What can happen is that air has less viscosity than water. That makes it easier for air to make its way up the stem, find its way behind the O-rings, and roll them out of place. Now, if your O-rings have been rolled out of place and you go to operate the valve, you run the risk of damaging those out of place O-rings. This event is rare, but we'll have Kent going into further detail and discussion on this later. And so once you've got those replaced, you're just going to reassemble everything as it came apart. Those are your two gland flange bolts. As I said, that's what holds the weight of the valve when you do have that suspended by those lifting lugs. And you're back in business. Now, in most situations, your most effective way to resolve your issue is to do a full bonnet swap. Because, you know, you may see water coming out around the gland. So you order a new one, but then you find out really it was the O-rings, and now you have to get those and wait for them to get there. But when you do a full bonnet swap or head assembly swap, the only thing left from the old valve is the body casting left that's connected to your pipe. Everything else is going to come as a new assembly. So for this procedure, you will need to turn the flow off upstream of the valve for the duration of this fix. So to begin this process, you're going to take a flathead and a hammer and break out the hot melt around each bolt. Some guys use a pick, but I've never had a pick on hand. So just strike the flathead right into the middle of the hot melt. It'll come out in pieces. Once you have your hot melt removed, take your Allen wrench and remove each bolt. Once you have all your bolts removed, you'll be able to remove your head assembly. Once you have it off, be sure to inspect the internal parts of the wedge and internal parts of your bonnet for any damage. And you may be able to find your issue. And with any luck, you can salvage the parts. Now your head assembly will come with all new bolts, so you can discard the old ones. And take your new head assembly. Make sure the wedge, in this animation, we didn't get the wedge in the upright position, but when you are performing this task, when you're reinstalling it, you're going to want the wedge in the upright position. It's going to allow for everything to fit in there better and fit in there tighter, and you're not going to end up trying to operate the wrench nut with your wedge down inside the body. And so as you can see our gasket here, that gasket, as we mentioned, is an incredible feature here because it, you know, if you're a car guy at all, you're going to know what the headers of your car look like, and the gasket's kind of the same way in that each one of those bolts that goes through that body is encapsulated by that bonnet or by that gasket as well. And so that gasket just provides a very last last defense against corrosive materials or anything that would possibly be getting through your seal. And again, your bolts just aren't going to see any of that. And so when you're reinstalling this, you're going to take 2 or 3 bolts and you're going to put them through the body, through the bonnet, and through the gasket, because anything over a 6-inch valve is kind of going to be kind of awkward for a single guy to do. And we don't want your fingers getting up underneath there when you go to set it down on the body. You're also going to want to make sure that you clean off all your surfaces and your body when you go to reinstall it, so that you don't have any dirt or grime that's going to get on the inside of there as well. Then you go ahead and place your head assembly back onto the body and insert your bolts. You're going to tighten your bolts in an alternating pattern for a uniform seal and tighten to 40 pounds of torque. These bolts should be able to turn in by hand for the first few turns. If they do not, then you may have something in the threads or cross-threading it, so back it out and try again. Once the bolts are tightened, you're ready to be back in service. And before you forget, be sure to take a silicone caulk and refill those bolt holes for continued protection. Once you've given enough time for the silicone to set, you're ready to bury again. All right, and so now we'll have our Eastern US sales manager, Kent Culbertson, join us. Kent's going to give us a rundown on the importance of testing with water. Kent, for those who don't know you, go ahead and give us a little background on your extensive experience in the waterworks industry and fill us on what we need to know about testing our systems.
Thanks, Sawyer. Real quickly, background-wise, I managed a utility in the late 80s through the early 90s, and then worked for a PVC pipe company for about 10 years, and then I've been with AVK now for 18. So we're going to talk a little bit today about testing with water, excuse me, versus testing with air. Primarily, AWWA installation standards C600 and C605 specify leakage test, not pressure test. And those are often misinterpreted. People will try to put as much pressure on the main as they can. But in fact, the AWWA C600 and 605, those standards state all air must be expelled from a new pipe for the leakage test to be accurate. So this comes into play pretty much weekly for distributors, because new water and sewer mains must be tested for leaks prior to final payment being made for the work. And they'll be dealing with contractors and cities to try to get that job closed out. If the tie-in for the new water mains with in the city limits, it'll usually be within 800 to 1,000 feet of a fire hydrant. But in a remote situation like a rural area or a subdivision, the new main may be more complex as far as getting a water source. And that's where you'll sometimes see air compressors, because the contractors will already have that on a truck and they just want to use the air compressor that they use for their high impacts and whatnot as a source, and they'll test with air. AVK strongly recommends that all testing be done with water, and AVK does not support testing under pressure with air. Testing with air is very dangerous because air testing is subject to the gas law, and in short, compressed gas is explosive, water is not. Viscosity comes into play. Air will leak where water will not leak, and when gas is compressed, it heats up and then it'll cool down, dropping the pressure. When gas warms up, the pressure increases, and in both cases you can get a false leak test. So it's very important to test with water, not air. Compressed air stores energy and can act like a bomb if the new piping system fails. And that's about it, Sawyer. If you have any more questions, get a hold of your territory manager or AVK Engineering, and we've got some papers and whatnot on that we can email you. That's it.
Awesome. Thank you, Kent. I appreciate your time and the information. So before we get going here, guys, we'd like to tell you about our upcoming webinars and events throughout January. We'll do a Series 27 hydrant overview, operation and maintenance, traffic repair kits, and troubleshooting. So stay tuned throughout January. Be watching our newsletter for registrations for these. And without anything else, again, my name is Sawyer Heidesch with American ABK. We'll go ahead and open the floor up to any questions.